Welcome. This video will walk through running the STREAMLINE Automated Machine Learning tool within its Jupyter Notebook run mode. This run mode is best for users looking to confirm that STREAMLINE has been installed successfully for use on a local computer, for running STREAMLINE in a notebook using your own computer's resources, which is generally expected to be faster than running in Colab Notebook. Also, running analyses on small to moderately sized datasets, and viewing output directly within the notebook, or for educational purposes. If you're unfamiliar with Jupyter Notebook, head to this link to learn more. Regarding advantages and disadvantages of this run mode, Jupyter Notebook doesn't rely on the free computing resources of Google Cloud, as it does when running the Colab Notebook, but rather it relies on your own computer's limitations. It also offers one-click running of the entire pipeline across all phases of STREAMLINE. It offers in-notebook viewing of results and the ability to save the notebook as documentation of the analysis. And it allows easy customization of nearly all aspects of the pipeline with minimal coding or environment setup expertise. As disadvantages, Jupyter Notebook can only run the pipeline serially, and is expected to have a slower runtime in contrast with running from the command line. Further, beginners will have the challenge of setting up their own computing environment, which often can take a little bit of troubleshooting. Regarding installation, we're going to first cover the prerequisites to running STREAMLINE that are relevant to both the Jupyter Notebook and command line interface run modes. First, you'll need to be able to find and use your computer's command prompt. For example, in Windows, you can open the Windows command prompt or use git bash. And in Mac, you can use the command prompt application called Terminal. You'll also need to install Git on your computer, and you can check out this link for more information. And you'll also need to install Anaconda, and again, you can use the link provided to learn more about that. To use STREAMLINE, we recommend installing or updating to the most recent stable version of Anaconda 3 that's appropriate for your operating system, assuming it's not already installed. When you install Anaconda, it includes Python 3 and a number of other common packages that are used by STREAMLINE. Now we're going to go over STREAMLINE installation commands that again are relevant for both the Jupyter Notebook run mode as well as command line interface run modes. After confirming that you have the prerequisites we covered on the last slide, use your command prompt to navigate to the directory on your computer where you want to save STREAMLINE, and enter the following commands one at a time. These commands do the following: download the most recent release of STREAMLINE from the GitHub repository, navigate to the root STREAMLINE directory where the package can be run, and install all other packages required by STREAMLINE on your local system. You can check out the file requirements.txt in the STREAMLINE GitHub repository for a complete list of these packages. Now you're set up to run STREAMLINE from its root directory. Next, to ensure the Jupyter Notebook is set up on your computer, you should also make sure that the Jupyter package is installed using the following command. To get started running the STREAMLINE Notebook, begin by opening Jupyter Notebook using the command Jupyter Notebook within your command prompt. Or in this example, I'm using the Anaconda prompt that was installed along with Anaconda. Within the web page that opens, navigate to the saved STREAMLINE folder on your computer and open the file streamline-notebook.ipynb, which is the STREAMLINE Jupyter Notebook file. From here, you'll find that running STREAMLINE in Jupyter Notebook is quite similar to running it within Google Colab. This Jupyter Notebook file is set up initially to run a limited demonstration analysis, applying all 9 phases of the pipeline. This includes threefold cross-validation, also using only 3 of the faster machine learning modeling algorithms, and applied to the 2 demo datasets, as well as a replication dataset paired with the custom HCC target dataset. This demo should take about 2 to 5 minutes to run, depending on your computer's hardware. After the notebook is open, you can run this demonstration analysis by opening the kernel menu and selecting Restart and Run All. At this point, the notebook will do the following automatically: run all phases of STREAMLINE on the demonstration datasets, and when completed, it'll save all output files, including automatically generated PDF reports, into an experiment folder named Demo Output within the STREAMLINE directory. Instead, if you want to run your own data in this Jupyter Notebook, begin by opening that same Jupyter Notebook file as we did in the demo. But this time, before running, you'll need to update the run parameters within the STREAMLINE run parameters code cells of the notebook. At minimum, you'll need to update the parameter demo run to false, telling the notebook not to run STREAMLINE on the built-in demonstration datasets. Also, you need to update all essential run parameters within their respective code cells based on the dataset's specifications. Further, you'll have the option to also update any non-essential run parameters within their respective code cells. And lastly, when you're ready to run, open the kernel menu and again select Restart and Run All. So now let's take a closer look at running your own data within the STREAMLINE Jupyter Notebook. For this example walkthrough, we'll assume that the prerequisites of Git and Anaconda have already been installed on your computer. So next, we're going to install STREAMLINE. Open up your command line. In this case, I'm using git bash. Next, navigate to the folder on your computer where you want to install STREAMLINE. In this case, I'm going to install it on my desktop. Next, paste or type the first command of the installation. And we can see that the contents of STREAMLINE have installed correctly, including the STREAMLINE Jupyter Notebook file. Next, type or paste the next installation command, changing the directory to this STREAMLINE folder. You can check the contents of this folder with the command ls. Now type or paste the third line of the installation. This installs all other packages required by STREAMLINE. Now we should be ready to go. Next, I'm going to open my Anaconda prompt and type Jupyter Notebook. After running this command, a web page will open up for Jupyter Notebook. Within this page, navigate to the STREAMLINE folder. In this case, it's on my desktop. And click on the file called streamline-notebook.ipynb, which is the STREAMLINE Jupyter Notebook. This notebook is effectively the same as running the Google Colab notebook in manual mode. To run the demo, we'd just click kernel, and then restart and run all. However, if we want to run STREAMLINE on our own dataset, scroll down to the Run Parameters section, and change demo run from true to false. This tells the notebook not to run on the included demonstration datasets, but on other datasets that we'll specify in the below run parameters. Next, go down to the section called Target Data Run Parameters Phase 1. Here, we're going to change some essential run parameters. Our target datasets are saved within demo data, and we have one replication dataset within demo rep data. So the first essential run parameter we're going to update is data path. This is the folder path to the folder with the target dataset or datasets in it. So here that's going to be demo data. Let's find out what its path is, and we'll update that in the notebook. Next, we want to update output path, which is the folder where the STREAMLINE output folder will be saved. In this case, we're just going to have it saved to our desktop. Next, we want to give our experiment folder a name. Here, I'm just going to leave it to my experiment. Afterwards, we want to make sure our class label, instance label, and match label are all correct for our dataset or datasets. In this case, our class label is class, our instance label is instance ID, and our data doesn't include a match label, so we leave this to none. Furthermore, we can also add a list to the following three arguments: ignore features, categorical feature headers, and quantitative feature headers. Any features specified in the ignore features list will be ignored in the STREAMLINE analysis, and any specified for categorical feature headers or quantitative feature headers will be treated either as a categorical or quantitative feature during the STREAMLINE analysis. For now, we're going to leave all three of these to none, which means that STREAMLINE will automatically determine the feature types of all features in the dataset, using the categorical cutoff run parameter defined below. Next, we're going to go down to the section Replication Data Run Parameters Phase 8. Since we have a replication dataset, we're going to leave Apply to Replication to True. And as such, we're going to want to make sure we have the right paths for the rep data path and dataset for rep run parameters. Rep data path is a folder that includes one or more replication datasets. And in this case, that's this folder demo rep data. So we're going to update this file path accordingly. And then we want to update dataset for rep, which points to the file path of the target dataset used to train the models that we're going to reevaluate with the replication data or datasets in the folder rep data path. In this case, the target dataset we're interested in is HCC data custom, so we'll update this run parameter accordingly. At this point, you can navigate down and modify other non-essential run parameters in the notebook as desired. Once you're ready to run the notebook, go up to Kernel and select Restart and Run All. Once the run is complete, we can see that we have a new folder on our desktop called My Experiment. Inside, we'll find the Streamline analysis results, including the PDF testing analysis summary report covering phases 1 through 7, an analysis folder for each target dataset, in this case HCC Data and HCC Data Custom, as well as a dataset comparisons folder. If we go into HCC Data Custom, we'll find a replication folder for the corresponding replication analysis of this target dataset. Inside, we'll find the PDF replication analysis summary report. We'll conclude with one quick consideration regarding Jupyter Notebook to run Streamline. Specifically, it can take multiple hours or longer to run this notebook on multiple larger datasets and/or using all machine learning modeling algorithms. For this, we recommend using a high-performance computing cluster if available. Thanks for following along on this walkthrough of running Streamline Automated Machine Learning using the Jupyter Notebook run mode. Please feel free to reach out if you're interested in collaborating or if you have any questions.